Okay, this is question 65 in chapter 16. Okay, it is about reaction between halogenoalkanes and ammonia. Now let's look at a very simple example of reaction between halogenoalkane and ammonia. I'm going to write an equation. Okay. So if I have chloroethane, okay, reacts with ammonia. This is nucleophilic substitution. Cl will be replaced, okay, by an amine group, which is NH2. Yeah? So there will be a byproduct formed in this reaction, okay, which is HCl. Okay, now this halogenoalkane, okay, I'll use the same example, the chloroethane. Can also react with amine. Amine means ammonia, one of the H is replaced by an alkyl group, let's say methyl group CH3 and okay H2. So it's an ammonia, but one H is replaced by an alkyl group. Now this one can also be a nucleophile because of a lone pair on the nitrogen, just like lone pair on the nitrogen in ammonia. So if this is the case, we will also get amine. Now remember, the ammonia, okay, lost one H in this reaction. So this amine will also lose one H. And then the N is bonded to the carbon. So remaining one H, then the other one, the CH3, is still bonded to N. Now we also get HCl as the byproduct. Okay, so it's very important for you to know these two very basic reactions first before we answer this question. Now there is another equation that I want to show you. Now if I have a very long organic molecule, and then this molecule, okay, has 6 carbon, for example, 6 carbon. Now I want to make the first carbon to be bonded to a Cl. Okay, and then I want the last carbon on the right hand side, yeah, this last carbon, to be bonded to an amine group, the NH2. Now because this molecule is long, okay, and they have two functional groups in the molecule, they can react with each other. Okay, so what will happen is this nitrogen with lone pair, okay, will attack this partial positive carbon. Okay, now let me number the carbon. 1, 2, 3, 4, 5, and 6. Yeah. So nitrogen will attack the carbon number 1. So at the end, this nitrogen will be bonded to carbon number 1, like this reaction. Okay, so let's try to draw this. So at the end, I'll get nitrogen, okay, bonded to carbon number 1. Okay, carbon number 1 is bonded to carbon number 2, then bonded to carbon number 3, number 4, okay, number 5, okay, number 6. Then carbon number 6 is also bonded to N. Okay, remember the byproduct will be HCl. So this one will be gone. One of the H will be gone. So nitrogen has only one H now in the product. Now the other H, they are still there. Okay. So this will be a cyclic compound that is formed when you have two functional groups in a long molecule that can react with each other. Okay, the reason why I'm showing you this, the third equation, is because this choline is actually a product from a reaction that is very similar to this reaction. Okay, so we want to find what is the original molecule that has the two different functional groups, okay, that can react and form a cyclic compound like this. So we are going to draw A, B, C, D one by one and write the equation and see what will be the product. If the product matches the structure of this choline, that molecule will be the answer. So now I'm going to erase all this. Okay. We are going to restart, okay, rewriting all the equation by using every answer. Now, I'll start with A. 1,1-dibromo 2-propylcyclopentane. Okay, yeah, I think we do not need to draw this because in the answer A, okay, it already contained a cyclopentane. So it is not possible for A to form this product, okay, because inside here there is no cyclopentane. So let's rule out A is not the answer. Now let's look at B. Also contain a cyclopentane. B is also not the answer. So we can only now look at C and D. Now let's draw the structure for C. One 4-dibromooctane. Okay, it's a very long molecule because octane, 8 carbon, 4, 5, 6, 7, 8. Okay, carbon number 1, there's a bromine. Carbon number 4, 1, 2, 3, 4. Number 4, there's another bromine. Okay. Right, I know it's a lot of work to draw all the hydrogen. Okay, now first let us react this with ammonia. Okay, now if we react this with ammonia, okay, one of the bromine group, one of the bromine atom will be replaced by NH2. Okay, so let's say this bromine is replaced by NH2. Okay, after that, this lone pair on the nitrogen will attack this carbon. Okay, so what will happen is you will get nitrogen. You have to remove one H, right? And then remove the Br. So this nitrogen will now be bonded to this carbon. Yeah, I need to number the carbon so that it's easier for us to trace which carbon, yeah, is bonded, and we will not miss out any carbon. Alright, so nitrogen is bonded to carbon number 4. And then it is also bonded to carbon number 1. This is carbon number 4, this is number 1. Now, carbon number 4 is bonded to carbon number 3. Okay, it's bonded to carbon number 2. Carbon number 2 is bonded to carbon number 1. So it forms a 5-membered ring. 1, 2, 3, 4, 5. Okay. Then carbon number 4 is bonded to carbon number 5, carbon number 6, 7, and 8. Okay, now let's put the hydrogen in. Okay, this is in a cyclic compound. So there's one H here. Okay, 2H. So let's look at the structure of coniine. Okay, it looks like the ring has 6 members. 1, 2, 3, 4, 5, 6. Here we only have 5. 1, 2, 3, 4, 5. So C cannot be the answer. No way. Okay. Now let's look at D. That's like our only hope now. When we erase all this so that we can make space to draw answer for D. Okay, now look at D. Yeah? 1,5-dibromo-octane. Again, 8 carbon. 7, 8. Let's number 1, 2, 3, 4, 5, 6, 7, 8. This time, okay, it's 1,5-dibromo-octane. Let's draw bromine atom bonded to carbon number 1, bonded to carbon number 5. Right, the rest are all hydrogen, yep. Now I'm going to skip this step, the drawing hydrogen part. Okay, so whatever I didn't draw, they are actually hydrogen atoms. Now, if this react with ammonia, so again, one of the Br group, the Br atom will be replaced by NH2. So let's say it's the first one again. Okay, so now this nitrogen, the lone pair, will attack carbon number 5. That means in the product, the nitrogen will be bonded to carbon number 5 and also number 1. Okay, carbon number 5 here. Now this carbon number 5 is also bonded to carbon number 4, 3, 2, and 1. Here carbon number 1. So bonded to carbon number 2, bonded to carbon number 3, carbon number 4, carbon number 5. Okay, of course this carbon number 5 is also bonded to these 3 carbons, 6, 7, and 8. Then this nitrogen has 1 H left. Okay, remove 1 H and Br. So in total, you removed 2 HBr. 1 HBr from the first step with ammonia. Second HBr after this amine group, okay, replace the Br here. So yes, this is the one that gives us the 6-membered ring. So the answer is really D.